All right, good afternoon, everyone. Thanks for coming out. I guess we're about halfway through the PDC now, depending on how you count the breakout sessions and whatnot. So good that everybody turned out for a late afternoon talk about tablet PC. My name's Shawn Van Ness.
And my name is Jamie Wakeam. Shawn and I are both program managers here at Microsoft. And we're going to spend a little bit of time this afternoon talking to you guys about tablet enabling your applications. So there's lots of new exciting innovations in the tablet PC space that we're excited to introduce to you guys here today, and as well as get your feedback on how we're doing this at this point. On the tablet PC space, we've got a variety of new features, starting mainly with handwriting recognition. There's lots of new features in terms of personalizing your handwriting recognition that you as an end user will get the benefit of being able to go and train the system a little bit based on some of the mistakes or writing styles that we don't particularly pick up, as well as a bunch of shell and usability enhancements. Things that you were seeing in the video there, like pen cursor feedback, giving little ripple effects when you touch the screen so that you know you've done that single click or double click. Flicks and panning just to make navigation and maneuvering through a tablet a little bit easier. And then for some new hardwares that will now be running tablet PC OS, touch support as well. So you'll now be able to use your finger instead of always having to use an EM electromagnetic digitizer for those devices.
Has everybody had a chance to stop by the hands-on lab yet, or the tablet PC track lounge? I know the hands-on lab has been really busy, but if you haven't had a chance to do that yet, you'll get a chance to get some hands-on experience with some of the new Vista UI features and tablet. But we've continued to make major investments across the mobile PC space, not just for end-user features, but for platform features, developer features. We have several other sessions here going on at PDC. There's a session tomorrow at the same time, I believe, about developing power-aware applications. And a few hours ago, we had a nice session on auxiliary display technology. That's the sideshow technology you saw in the keynote. And data synchronization continues to be a strong point of interest for developers in the tablet and mobile space. There's a session tomorrow on data sync. There's no session on touch screen support per se. There aren't really any new touch screen APIs, but a lot of work has been done in the underlying platform to support touchscreen devices, and that's really interesting. If you haven't had a chance to play with some of the new touchscreen units, like the little Fujitsu that we have up here, it's a good chance to stop by the expo hall and play with those.
So not only do we have lots of innovations in the tablet end user side of things, a lot of innovations on the mobile PC side, making PCs more usable. Well, what we're all here for is more code, better code. And what Shawn and I are primarily going to talk about today is two new sets of APIs that we have for Windows Vista. The first one we're going to talk about is ink inside of WPF, which is simply how we collect and render ink in WPF-based applications. And then we're also going to talk about the second generation handwriting recognition API called the ink analysis APIs. So more on those in a minute.
Sure. Can I get a quick show of hands? How many people here have experience developing tablet PC applications with COM or Windows Forms? It's about 40 or 50% of you. That's pretty good. That's about what I'd expect. So for those of you who have experience with our existing platform, the first thing to note is how we're sort of refactoring the platform, where traditionally we had handwriting recognition bundled in. The APIs for handwriting rec were bundled in to the rest of the ink collection and rendering APIs. They're all right there in Microsoft.ink.dll. Now we're sort of branching out into different presentation tiers, where we're going to be doing ink collection and rendering natively in Windows Presentation Foundation. And so it follows that the second generation handwriting recognition is sort of factored separately from that. And that's the ink analysis SDK, which Jamie will be talking about in the second half of the hour. But having ink in Windows Presentation Foundation is really interesting. It's all built right into the core Avalon assemblies. There's no separate SDK to download. And that's sort of a hint of things to come. You see the direction of tablet PCs becoming a lot more mainstream lately. It's both becoming more mainstream in the software development environment and more mainstream in hardware environment as well.
So speaking of hardware, we've got a ton of innovation on the hardware side. A lot of you guys stopping by the booth, you've had ability to see a bunch of these different hardwares. Hopefully got a chance to play with them a little bit in the test drive lounge. Just to show you the breadth of hardware, what I've got here is Gateway's new model. This is a widescreen tablet PC, which the screen does rotate around and give you that full tablet functionality. They've got a couple cool little like magnetic hinges to lock the stuff down here. All the way down to some really super ultra portable systems like this Fujitsu Lifebook series. And this guy's is running Longhorn, which we managed to put on this system just yesterday. And this machine is touch enabled as well. So no necessary EM digitizer for this guy. You can just use your finger to tap away on the screen there. So a really wide, exciting variety of different hardware manufacturers. Too many to mention specifically, but a great breadth of diversity on hardware.
Is it really running Longhorn, or is it running Windows Vista?
It's running Windows Vista,
All right.
yes.
You owe a nickel to the swear jar.
Thank you.
Yeah, and Jamie didn't point out, we have a Toshiba M4 up here that we're actually running all of our Visual Studio coding demos on up here. This is sort of the big iron tablet PC of the moment. It's got a 6 Series NVIDIA graphics card in it, runs Avalon applications really swimmingly. Now, there's two things to really notice about the hardware ecosystem right now. One is the breadth of the spectrum of hardware form factors is really growing. And the other is the cost delta between similarly configured tablet and non-tablet laptop models is really decreasing. You're getting to this space where the cost delta is down below $200 in some instances. And I think we can all remember a time when, gosh, maybe just 4 years ago or so, when you go to the store, you could buy a laptop and you'd get the option of whether you wanted the integrated wireless networking or not. It might cost you an extra $100 or $150. Once that price delta got down below a certain critical threshold, pretty much every laptop now has integrated wireless. If you went to the store today and bought a laptop and it didn't have integrated wireless, you'd take it back, right? And tablet PC is sort of converging to that same level of ubiquity, hopefully. Maybe that'll happen in the next few years. So let's talk about some code here. Digital Ink and Avalon. Oops, excuse me, Windows Presentation Foundation.
Quarter for you.
Yeah, quarter for me, we're even. What does that mean? The primary thing we're doing here should not really be that surprising for those of you who've used our existing platform. Our primary focus is on feature parity with everything we've done in the common Windows Forms world. We collect digital ink, we render it, we have all the same editing modes. We've gone a little bit above and beyond. First of all, we've tried to make it a little easier, just simplifying the programming model wherever possible. We tried to enable some new scenarios that were difficult or impossible before. But it's also a little bit more tightly integrated with the rest of the presentation framework. You'll see stylus events on all the UI elements, for example, right alongside mouse events. Before we go any further, let's just switch over and see what I'm talking about. What do we see?
Yeah, give it a hard push. There you go.
There we go. So Jamie's just going to fire up a new Visual Studio application while I talk here. A new Avalon application. Yeah, the wizards still say Avalon, and the XML schema still says Avalon. We'll see if we ever get around to getting that fixed. So Jamie's just going to add an ink canvas element between these two empty grid tags. And go ahead and hit F5 there and see if that works. Ink canvas is the centerpiece of ink collection and rendering support in Avalon. And it really is as simple as that. There's no extra assemblies to reference or any of that. Ink canvas is a first-class citizen in the Windows Presentation Foundation. Cool, thanks, Jamie. On the right slide. So having tablet platform features in WPF, what does this mean? Like I said, there's no separate SDK to download and build against anymore. There's no separate runtime to worry about redistributing apart from WinFX itself. Now, this is really cool, but it's only really half true. The one thing we're not doing in WinFX is advanced handwriting recognition. we have the ability to apply input scopes to UI elements and text boxes, and we'll see this demoed a little bit later. But if you want to do advanced free-form handwriting recognition, you'll need the ink analysis SDK, which is what Jamie will be demonstrating in a few minutes. But for a large class of applications, ink is really all you need. If you want to annotate some photos and share them with your friends, for example, all that you need to do that is built right into WPF. If you want to make some sort of peer-to-peer chat application, serialize ink strokes and send them across the wire and display them on someone's desktop machine, WPF is all you need. And the motivation for doing this was really, you know, a lot of the most popular tablet PC applications weren't really tablet PC applications at all. They were features of applications like Ink and Instant Messenger. And how many people have used Ink and Instant Messenger? Yeah? Yeah, good deal of you. It's cool. So it's an Ink feature, but it's not necessarily a tablet feature, right? People who don't have tablet PCs can see the ink on the other side of the wire. This has become really popular. There are a large number of application scenarios that this enables. So before I go too much further, I just want to tackle this topic head on. So a lot of people, when I meet them at cocktail parties and they ask me what I do for a living, I say I'm a program manager for Tablet PC and Avalon. And they look at me funny, like, what could Tablet PC and Avalon possibly have anything in common? And so, you know, you've all been to the keynotes and you've been around PDC for a few days. You've seen some incredible Avalon demos, no doubt, full of gratuitous 3D spinning cubes and all sorts of UI effects, right? Am I right? And, you know, of course, if you've got a UI framework that allows you to do that, and you're going to stand up on stage and give demos, you're going to give the flashiest demos you can possibly give. But no one's really suggesting that those demos are the best models of user experience to develop real applications. And indeed, if your users are going to be walking around running on battery power, they're probably not the best examples of user experience. And now the truth is, there's nothing built into WPF that really holds a gun to your head to, you know, make your user interface into a 3D spinning cube. On the contrary, there are a lot of things built into WPF that are really points of synergy between tablet and Avalon. Just the fact that everything rendered in WPF is DPI independent. The pixel space in Avalon is completely logical. It's not tied to physical dots per inch. We saw earlier on this hardware slide this growing spectrum of hardware form factors. Can you imagine how are you going to craft a UI that scales somehow between a little 8-inch motion computing running at 800 by 600 to one of these Toshiba M200s that runs at 1400 by 1050 at 12 inches. One of those devices is about 80 DPI. The other is about 130 DPI. It becomes really hard to do that with traditional tools, but WPF makes it a lot easier. Vector graphics, of course. You know, your users might have smaller screens. It doesn't mean they need to squint to try to read everything, right? That's just shrunk down and rendered. Vector graphics allows you to scale text a lot more fluidly. I'm going to switch over to Jamie here. He's running an application called the SDK Doc Viewer. This is just a little sample application built with WinFX. It's just a rich client viewer for our own SDK documentation. This uses a control called the flow document, a document viewer. And he's got a little zoom wheel down at the bottom here that he's playing with. You can see how well the text zooms in and out and smartly reflows from one column to two, and it realizes it has enough space. The reading experience on tablet PC is a killer experience, right? And Avalon just makes it better. What about rotation? Yeah, Jamie asks, what about rotation? So another hard problem traditionally in tablet PC development is making a UI that scales not just from different physical sizes and DPI sizes, but scales to different aspect ratios, right? The portrait versus landscape problem. How many of you have tried to craft a user interface that somehow intelligently redesigned itself and when the user switched from portrait to landscape? It's pretty hard. Outlook does it pretty well. That's probably the only application that springs to mind that does it well. But in Avalon, the positioning of elements is all just completely relative, right? You've probably seen that in a lot of the Avalon demos so far at PDC. Jamie, if you just switch from portrait to landscape, will it, yeah, there you go. I don't remember if it was showing two columns before, now it's showing one. So you see how the flow document was just intelligently makes the best use out of the available screen real estate it has. You get all this for free in Avalon. To 3D or not 3D, that's the question, right? At the end of this talk, we'll have a slide showing some of the other presentation codes that are interesting. Alexander Stevenson's giving a talk tomorrow or Friday, I forget, about performance in Avalon. And one of the things he's going to talk about is the tiering API, the ability to have the best of both worlds, to have a single application that restyles its user experience based on the hardware capabilities and indeed whether or not your user's mobile, running on batteries or not. Last but not least, over the past few years, experience has shown that tablet users are really like out-of-the-ordinary user interface designs. This has just sort of grown organically, and we've ended up with applications like the snipping tool. If anybody's used the snipping tool 2.0 in the Microsoft Experience Pack, it's a free download, must-have, if I may say so, for tablet PC. But if you look at the UI, now this is not an Avalon UI. This was written with Windows Forms and C#, but it's just many thousands of lines of painstaking procedural code to lay out all of these elements and do things like brushed alpha gradients and whatnot. WPF provides a declarative programming framework, and in the future will provide some tools to make this a lot easier to develop this type of user experience. Indeed, even the tablet PC input panel, there's a screenshot of the Windows Vista tablet PC input panel. Even that's a great example of a type of user interface that would be very much more easily constructed in XAML than with the many thousands of lines of C code that it was written in. So, in truth, there are a lot of points of synergy between tablet PC and WPF. Thank you. All right, enough of all that. Let's see some more code. We've already seen the ink canvas element in action. Let's see a little more about it. So about half of you have some experience with our existing platform, and the question may have already jumped into your mind. If you're familiar with ink collector, ink overlay, and ink picture, how does ink canvas map to those? Which is it the most like? Really, ink canvas serves as a superset of all three of those, and we'll see it in action. By default, the biggest difference between ink canvas and ink picture, for example, is that ink canvas collects ink over the top of any of its child elements. This is an interesting point of departure from Win32. In Win32 world, any single pixel on the screen belonged to one and exactly one window, right? It might have been a child window or it might have been a top-level window, but you really didn't have this notion of two different windows sharing airspace, the way Nick Kramer likes to put it. But in Avalon, sibling windows can share airspace. You can have partially transparent siblings that overlap each other. And events aren't routed to just one element and only one element. If you've seen how events in WPF are routed, they tunnel and bubble, right? They tunnel down the stack, then they bubble back up. So any single point on the screen really doesn't belong to exactly one element. It belongs to potentially a stack of elements at that one point. So how do you decide in a programming model which of those elements you collect ink over and which you don't? Well, we use the flexible layout of XAML to handle that fairly elegantly. So I'll just flip back over to Jamie here. He's got an ink canvas running. What happens if you add a button as a child of the ink canvas there, Jamie?
Actually, let me just make this a little bit bigger.
Yeah, we'll do the standard demo trick of adding a render transform.
What the heck
No?
is it? Well, we'll do it the old-fashioned way then.
I think your IntelliSense is messing up on you there, Jamie.
Yeah. Let's
That'd
give
work.
that a whirl.
So Jamie's run this. He's got a grid with an ink canvas and a button as a child element of the ink canvas. So the ink canvas is still alive and well. What happens when you click the button? Oh, you can't. OK. So that's interesting. We've added a button as a child of the ink canvas, but we can't click it anymore. This is really by design. This is the way that you provide a XAML backing to your ink canvas to allow you to collect ink over arbitrary child elements. Now, to get around this, What happens if you take that button element and move it outside of the ink canvas? Just make it a sibling of the ink canvas, but higher in the Z order. We'll set the width and height there so it looks good on a grid.
Not quite.
Close enough. But now we should see we get much more of a behavior. Yeah, it's very much more similar to our existing common Windows forms, where we're collecting ink over just one element, the ink canvas element, and not the foreground sibling elements. So you get the flexibility there with ink canvas to do it either way. You can lay out elements as siblings higher in the Z order, and they appear above and don't participate in ink collection. Or you can have them as child elements in the background. And we'll see in a little bit, you can dynamically switch between the two. Thank you. So ink canvas editing modes. Once again, this is no real big surprise for those of you familiar with ink overlay and ink picture. We have all the same editing modes. Inking, of course, erase by stroke, erase by point, and the lasso selection mode. But we've gone a little bit further here. One of the interesting things, the actual strokes as they're rendered on the display in WPF, they're just elements in the visual tree. And we realized early on that the code we wrote to select those elements in the visual tree and manipulate them, the same code pretty much applied to any other element you could throw into the tree if you wanted to. Why not just make it work? And we did. So I'm just going to flip back over to Jamie here. What happens if you add a text box as a child element of that ink canvas? Now, just adding a text box on there, we see wouldn't really get us much. We would just collect ink over the top of that text box. It wouldn't really be alive. You couldn't really interact with it. But if we change our editing mode to select, go ahead and change the ink canvas editing mode there. All right, now we should be able to interact with that text box. So I have a text box in the upper left-hand corner there. I don't know if you can see it. It's just white on white. But we're in selection mode. This is the same lasso selection tool that you all know and love for interacting with strokes and stroke collections. But it works with text box now. You can grab it and move it around. It's live. Can you actually click in the text box and type something there? Yeah, there you go. So it's a live text box that you can edit and interact with on the ink canvas surface. This makes it a lot easier to develop these mixed text and ink type of editing experiences that you see in Windows Journal or Microsoft OneNote. Oh, and last but not least, this was a nice little ad. We have probably a dozen or so of these little tiny features that were difficult to implement in the existing platform, and now we've tried to make it much more easy. Editing mode inverted. If any of you have ever written the code to try to detect when the stylus is inverted and switch the editing mode from ink to erase and then remember what mode you were in to switch back, it wasn't rocket science, but it was about 20 or 30 lines of code to get right. Now we just have a property on ink canvas. There you go. Just playing with it here while I talk.
Yeah, all I did was simply remove that editing mode from equaling to select and added editing mode inverted, set it to erase by point.
Excellent.
Go ahead and compile that.
So now you've got ink collection, and if you flip the stylus over, we have the point erase. Now there's another point of synergy between WPF and tablet PC. I don't know how it looks on the big screen, but the flicker-free rendering that you get with Windows Presentation Foundation, right? Everything you see on the screen, none of these things are really being drawn to the screen in response to a paint message the way it used to work. These things are just elements that exist in a tree, and when we do the point erase operation, we're just tracking through those visual elements in the tree, splitting some of them up, depending on where the eraser path crosses. And that's it. The rendering just happens. It's completely flicker-free rendering. That was always a real challenge. As soon as you tried to do any sort of non-trivial editing operation before, you had to work really hard to try to get your rendering to be truly flicker-free. And Avalon makes that a lot easier. Thanks, Jamie. So I'll talk about this just a minute. One of the design philosophies that we tried to hold to in building Ink Canvas was that it should meet everybody's needs, but it shouldn't really be anything more than the sum of its parts. One of the requests we got a lot was, we have these controls like Ink Picture, but they're just black boxes, and they have a lot of built-in functionality that can't really be overridden or changed. For example, what if you don't like the lasso selection mechanism where you draw the irregular region? What if you wanted to have something like a more traditional rectangular selection mechanism? You were pretty much out of luck. There was no point of extensibility in there to somehow change the selection UI. And Ink Canvas doesn't have those points of extensibility either, but it is just the sum of its parts. It's composed of an element called an ink presenter. This is a decorator element, as it's known. The ink presenter is what handles the static rendering of stroke visuals in the tree. Dynamic render. If anyone's familiar with the real-time stylus plugins in our existing platform, it has a class called dynamic renderer. It's the same thing in WPF. This is the guy who listens to the stream of stylus data coming from the hardware and renders it into the visual tree as quickly as possible. And the stylus events on UI element. I mentioned these earlier on the UI element base class. It's pretty much a one-to-one mapping with all the mouse events. Mouse down, mouse move, mouse up. You'll see a corresponding set of stylus events. Stylus down, stylus move, stylus up. These allow you to get all the information you need on the UI thread and populate your own stroke object model. So maybe you don't like our new stroke collection object model. You want to populate your own document object model. We give you all the information you need to do that. And there's the list there. You can see they map pretty much one-to-one with mouse events, except for stylus in range, stylus out of range. Those are unique to the electromagnetic stylus coming in range or out of range. So I'll talk a little bit more about how deeply integrated Ink is into Windows Presentation Foundation. Some of the cool benefits we get almost by accident, just by being in the same presentation tier, in the same rendering pipeline as WPF. There's an acronym MIL, M-I-L. You may see these in some of the other talks, maybe not. If you play with Avalon projects for a little while, you'll see some DLLs like milcore.dll. MIL was originally an acronym that stood for Media Integration Layer. This was the effort to unify all these different presentation tiers we have, right? We have things like DirectX versus GDI versus GDI+. When Avalon started, it was really an effort to try to unify all these different presentation technologies into one consistent programming model in one single tier. And a great example is video. Something that was very, very difficult to do, near impossible to do with our existing platform, was to collect ink over live video. There were just two different pipelines. The ink was being rendered on screen with GDI and GDI plus calls. The video was going through the DirectX pipeline through hardware acceleration. And there the two shall meet, right? If you've ever tried this, it's almost an exercise in frustration. But it pretty much just works for free in Windows Presentation Foundation. So flip back to Jamie here, and you've still got that Ink Canvas up. If you add a media element as a child of the Ink Canvas, and we happen to have some sort of video laying around. This is one of the video components in the video we were showing earlier, right? The train ABI. And let's see if this works. And so we have a little video running up here. This is a woman sitting on a train, and as you can see, we're just collecting ink in real time over the video. How cool is that? Another point here, I mentioned this earlier, we're talking about handwriting recognition. We're not building any handwriting recognition libraries into WinFX per se, but we're not leaving you completely high and dry here. Like I said earlier, there's sort of different classes of applications you can consider. There are some classes of applications that are just ink-only applications, like annotations over a photo library. And if any of you saw Project Max on one of the keynotes, there's some work going on right now to add ink annotations into Project Max. Once they saw how easy it was, they jumped right on it. It's going to be really cool. So you've got that class of applications. You've got another large class of applications that are sort of the rich, full-page, note-taking type experiences. And that's where you really want advanced, full-featured ink analysis and parsing, and this is what Jamie will talk about here in a few minutes. But then there's that middle class where maybe you have some ink, maybe not. Maybe you don't really have full-page note-taking type experiences. Maybe you just have more of a traditional form fill application with some text boxes, and you want to be able to do the handwriting recognition, provide the best handwriting recognition experience as possible. Did anybody play with the Set Input Scope API that was released back with Tablet PC Edition 2005? It's part of the Tech Services Framework. Koji, very good, sir. Koji did. I did. It's a very simple API. It's just a Win32 API, part of Tech Services Framework. As far as low-level APIs go, it's very simple to p-invoke from managed code even. But the problem was, obviously, you can't p-invoke to native methods from partial trust, for example. And it was a little bit of a pain. We never really got around to providing a managed wrapper for input scope until now. Indeed, any UI element can have an input scope applied to it in XAML, in the markup. And this same input scope is picked up by both speech recognition technologies and the handwriting recognition technologies. And we'll see if we have them here. Jamie's gone ahead and just added in the input scope equals URL attribute here. And go ahead and hit F5 and see if it works. We have a bug right now in the current build of Vista Beta 2 where the input scope doesn't always.
Let me give me a.
If you do editing mode select, it should work. Okay, I think it's going to work here. It's just a little slow. It's a little sluggish. Did it go?
Yeah.
Great. So you see the tablet input panel popped up, and you notice the extra row of blue buttons there for http:/.com, whatnot. These are the same UI features that you've seen in Windows Tablet Edition 2005, just skinned in the new tip there. But it picked up on the URL hint we had on input scope and used it. So that should make everyone's life a lot easier for making the handwriting recognition experience a lot better in their applications.
Right. So I just took that input scope out, and again, the web tags just disappeared there in that situation.
Excellent. Thanks, Jamie.
So that probably is leaving most of you wondering, okay, well, we've talked a little bit about how we get handwriting recognition working inside of WPF, and using the text input panel is a good way to do it when you don't natively want to accept ink into your applications. But when we actually do want to integrate ink deeper into our applications, that's when we turn to our second generation handwriting recognition APIs, what we're calling ink analysis. Now, for those of you that have used the V1 APIs before, what we basically did was we've taken the recognition context class and the ink divider class and combined those into a new single API called ink divider. We originally went down the design path. We tried to keep things separate, but the two technologies just converged too much to the point where, in order for us to provide the most benefit, we felt we had to come up with a new API and combine these together into a single set. Now, I'm going to talk a little bit more specifically about what ink analysis covers, but before I do, I want to touch a little bit on the redistribution side of it. When we architected the ink analysis APIs, we wanted to make sure that we could take all the existing common WinForms applications that are out there and give them a mechanism or a way to get access to this technology. One of our internal clients, OneNote, is an unmanaged application, and they wanted to make use of this technology as well. So the way we architected this was by first creating a core DLL, and this happens to be a managed DLL. It doesn't depend on any of the Avalon types or Windows Forms types, but does depend on the 1.0 CLR. And then on top of that, we simply created a COM interop layer. That COM interop layer allows any COM-based application to interface with the ink analysis APIs, basically passing us in packet data. Same thing goes for Windows Forms applications. There's a Windows Forms wrapper layer that exists to allow any of you using the current stroke type for WinForms application. And then finally, an Avalon-based layer. For those of you that now want to collect ink through Ink Canvas and take the stroke type from the Ink Canvas, you can pass those into the ink analysis API. So again, this is how we're going to get to our handwriting recognition results and our layout analysis results. So to put that all into deeper context, we're going to show a couple demos here that help highlight the types of things that you can detect with the ink analysis APIs. So we're going to flip back over to Shawn here, who's going to load up. I think it's already running there. Oh. And what we have here is just an internal test application that we use. So we're going to start. This is a WinForms-based application. Then we're going to move over to a WPF-based application in a minute here. So as a quick example, if Shawn just goes ahead and starts writing out a line of ink here, you'll notice on the left-hand side, and don't worry if that font's a little small there, I'm going to come back and show you a better version of this. But what's actually happening is we're collecting all this ink as he's writing. We're sending it off to our layout analysis engines. It's doing things like writing drawing classification. So for each stroke that we're authoring there, the analyzer is working on figuring out whether we think it's a writing stroke or a drawing stroke. All the drawing strokes we kind of set aside into one pool. All the writing strokes we send to another pool. Writing strokes we further break up into paragraphs, lines, and then we take those and we send them off to the recognizers. Now, we support recognition over in 10 different languages. So what we'll do is we'll detect what language the current system is in. Basically the same thing you use if you're doing multi-language input from a keyboard. And looking at the language ID of the active input thread, we'll then go and try and find a recognizer that matches that locale. Once we do that, if one is found, we send it off to that recognizer to find the recognition results. All those results are then reported back to you in a single structure. Now, in the multi-language recognition scenario, if we don't find a recognizer that matches the current input language, we just simply don't recognize it. But you as the developer can override that and choose to send it to a different recognizer if you need to, and basically force it for a particular recognition. So not only do we do writing drawing classification, we can also detect some basic shapes for that pool of strokes that make up the drawing. So Shawn, if you just want to go draw out a big square there as a quick example. Now, we're not detecting a full rich set of shapes and all that kind of stuff. We're just starting off with some of the basic stuff here. And on the right-hand side there, kind of as we were doing this, some of this stuff was getting analyzed as writing, some of it was getting analyzed as drawings.
Yeah, the standard disclaimer here, the ink analysis hates my handwriting.
Yes. So one of the things that is a little bit different from what we had with Ink Divider was a heuristic-based engine. So we didn't really rely on a lot of training data. We kind of just more fine-tuned it to the best set of data we had. While with Ink Analysis, all of the layout engines were completely rebuilt and re-engineered to be learning-based. So there's a large neural net, very similar to how we do handwriting recognition. And so as we're sort of new at our infancies, we're still collecting as much free-form ink data as we possibly can, and we're vigorously trying to train these engines to get the best set of results. So we kind of ended up that where PDC fell for us this year and where we were in our training cycle didn't get us the most glorious sets of results, especially for people like Shawn for some reason. So we need to get him to give us more training data to balance this out.
I promise to more actively participate in the training sample collection.
Right. But if you bear with us while we get through our beta stages, I promise you this will be better by the time we release. The point I'm trying to make here, though, is that this rectangle that Shawn's written down at the bottom should have been detected as a rectangle there. And if with a little bit of hover feedback you saw there, it did actually come back and tell us it was a square. So that's kind of our basic shape detection. Now, the other thing I want to point out is annotation. So we've kind of very ambitiously tried to push down the route into annotations. There's generally two types of annotations people can do. We can do ink-on-ink annotation. So if, Shawn, you go ahead and underline one of the words up there. Once we go back to ink mode, the analyzer is going to kick in again and go do its magic. And if all went well, that should come back first classified, in this case, since it's an underlined, as a drawing. And you notice on the tooltip hover there, it does say underline. So that's giving us the indication that this is now an ink drawing that is underlining a particular ink word. And we've got in our API access to find the linked information between those two objects. So we're going to go into a little bit more detail on some of this stuff, but it's going to hopefully give you a little bit of an idea of what ink analysis is. And the one other point which I almost forgot there is ink on text annotations. So one of the things that we've done with this new API is we provided a mechanism to allow non-ink objects, whatever it is in your application, whether that be text, whether that be images, whatever other kind of native objects you might want somebody to annotate or create or find out anchoring information. From the ink analyzer's perspective, we don't really necessarily care if it's text or image or just a complete foreign object. All we care about is the 2D or the rectangular location of that element on the page. So once we're told that you've got element A and element B in occupying these regions on your page, and the user comes along with their pen and they create an ink stroke all the way around that object, we can look at that and say, hey, this ink stroke is containing or is annotating that object. Don't care what that object is, but you care about it. We give you that little bit of information to do whatever you want with it. You move that object, you move the annotation, you delete the object, you delete the annotation. You've got the freedom to choose what to do there. A couple other things we did with ink analysis was to really help support the form scenario, which we know is vibrant in the tablet community. We looked at how to make the sort of that scanned paper form process of filling out that a little bit easier to develop. And what we've kind of traditionally done, or it's a little bit harder to do, is you have to do single cell input. So for each input field, you got to go and recognize the ink and keep it constrained inside of that field. Well, that doesn't feel a lot like paper. When you've got a paper form, you can write outside the lines. So with ink analysis, we now support the ability to, within a single instance, define multiple areas of expected input. We just simply call these analysis hints. These analysis hint objects take guide objects, word lists, input scopes, or factoids, depending on which terminology you'd like to use there. They both mean the same thing. And allows you to define multiple ones on the page. Now, what this does for us is it gives us neighboring contextual information. So if I know that you've got ink written in one field on the left, ink written on the other field on the right of the page, we can help figure out what ink strokes get associated to which of those fields once you've told us where those fields are. And like I was mentioning with the annotations, that's just a simple 2D location on the page and what type of input you expect in that location. Multi-language I already touched on a little bit earlier. Thirdly here is the ability to persist our results. So in the first version of the SDK, we did give you the ability to persist recognition results, kind of a little bit buried in the API in terms of how you get to it, but you could do it. Well, with ink analysis, we've basically integrated this into ISF, so you can simply call a save method on the ink analyzer, and it will give you ISF, which contains the results. Now, not only does it contain the full set of results, it'll contain partial results. So if your application needed to suddenly shut down and we hadn't quite finished doing our recognition or the analysis operation, you can abort us, you can save that current state. Next time your application is loaded up, we'll just pick things up right from that position where we left off. Okay, so let's dive in a little bit to how we use ink analysis. So we don't have native support inside of XAML like ink canvas recognition results because we don't want to necessarily overtax the ink canvas, and we also had some distribution restrictions that prevented us from actually shipping with Windows Presentation Framework. So we are a separate SDK. We're part of the mobile PC and tablet PC SDK. That a little bit of tax for you guys as developers, but we hope that gives you more flexibility because now you can choose to distribute us with your application if needed, or leave us behind if we don't fit your application. The ink analysis APIs is about a megabyte of data compressed. Uncompressed is about 4 or 5, and the reason why it's so large is simply because the ink analyzer has all of that training data I was telling you about in there. So we've been a little bit sensitive to the size of stuff, and we felt it was safer to kind of push it off in its own separate SDK. And I'll tell you how you can get that SDK at the end of the talk. So to get going on ink analysis, we're going to first start off with the simple synchronous case. So if we flip back over to Shawn on the machine here, we've just simply got that ink canvas project we had going before. We're going to start off by adding a couple references to our project. So we've got the SDK already installed in the system. And let's just go ahead and add our two assemblies. So we're going to start off by first adding that core assembly I talked to you guys about. And if we scroll down to the Microsoft section there, we want to add, actually one up.
Thank you.
Yeah, we want to add the ink analysis core components. So this is our main component. Now, if any of you guys have done real-time stylus input collection, and you don't actually use a stroke object, that's okay. I'm not gonna fret about that. You can actually take whatever packet data you've collected from RTS and you can send it straight to this base layer, and you don't even have to worry about using our stroke object. Hopefully, our stroke object does provide value to a large portion of you, but for those of you that got a more customized app and you don't need our stroke data, you can still get to the recognition results and the analysis results without having to construct a stroke. So then the second one we're going to add here is the WinFX library. So this is how we're going to get to the WPF-based results. If we were doing a Windows Forms one, we would just go ahead and add that ink analysis managed library. And if we were doing a COM application, we'd be over on that COM tab, and we'd be adding a reference to iacom.dll.
Oops.
Yeah, so add the WinFX one.
There you go.
Okay, so
So
now
Amy was saying that the WinFX assembly there is sort of a strongly typed wrapper around the ink analysis engine. It's strongly typed to take in the WinFX stroke object model as opposed to the WinForm stroke object model as opposed to the raw stroke object model.
right. Okay, so now we've added the reference to this, the compiler will know where to find stuff. Let's flip over to the code behind file here for this project, and we're going to go ahead and add a new namespace. We're going to add a using statement so that we can get access to the system.windows.ink namespace, which is where you will find all of the ink and ink analysis classes and types. If we were doing a Windows Forms project, we'd in addition want to add a using statement for Microsoft.ink, which is where all the Windows Forms-based components are listed. So let's go ahead and add in an ink analyzer. So we'll just define a new variable here. And then let's go construct a new instance of that.
Just right here in the constructor.
That's a great place to put it. And now when Shawn does this, he's actually also going to have to add a reference to the current thread's dispatcher. And this is just simply going to allow us to synchronize the events if we're doing a background analysis operation. So we raise those background events to tell you various things like we're ready, or if the user wants to abort the operation. We need a way to just basically hook the main UI thread to that of the background thread.
Have you guys seen much about threading in WPF yet, this PDC so far? When you see dispatchers used in WPF, think iSynchronize Invoke from Windows Forms. It's the standard protocol for taking a chunk of work and moving it from one thread to typically the UI thread.
Okay, so now that we've got a new instance of an analyzer set up here, the first thing we need to do is we need to tell the analyzer what strokes we want to analyze. So just for the sake of simple explanation here, let's go ahead and I guess perhaps on a button click would probably work best here.
Okay.
We'll just dump all of our
Back.
ink canvas data from there. So we've still got our ink canvas. Shawn went ahead and added a name to the ink canvas. He just called it ink canvas 1. That's so we can simply reference that ink canvas from our code behind file. And then we've got our text box left here, and we've got our button here, click me, and in this case, let's just add a click handler. You just button click.
Button click. Very good.
And so let's go ahead and handle that button click event, conveniently commenting out the uncommenting the sample code there. Okay, and so all we simply need to do here is let's do inkanalyzer.addStroke. And in this case, since we're doing all the strokes, caught by the casing there. Yeah. In this case, since we're just going to add all the strokes from the canvas, you could selectively choose it. If one area of your application was expected to have analysis results, another was not, you could filter out some of the strokes. In this case, we'll just add them all. So let's add your canvas in here. I forget what you called it now.
Hold on a sec. The IntelliSense has to catch up a second here.
Yeah. Just a quick recompile there, which should be good.
Like that?
Looks good. And so now that we've told the ink analyzer about the strokes that we want to analyze, we can just simply synchronously go ahead and call inkanalyzer.analyze. This will go off, perform the operation, in this case on the UI thread. So we'll just do an inkanalyzer.analyze.
Boy, I need to learn how to stop doing that.
And then when that event, or sorry, that method returns, we can just simply call inkanalyzer.getRecognizedString to get to the recognition results. If we wanted to go through and evaluate all of the layout information that's calculated, there's actually a tree, which I'm going to get to in a minute, that we can explore off of the ink analyzer called root node as the starting point of that node. And then let's just flip back over to your XAML there, and for your text box 1, we'll just go and we'll stuff the results of this data in text box 1. Perfect. So let's go ahead and run this app.
Oops, our button is almost off screen.
Well, just blow it up. Go full screen there, and you should hopefully be able to hit it.
No,
it's
everything is
synced.
relative in XAML.
Awesome.
It's good enough.
And I'm going to cross my fingers that Shawn's big T doesn't throw the analyzer for.
Oh, no good.
So, anyways, you get the idea of how you can pass the ink strokes into the analyzer and synchronously do stuff. No. Okay, so that was basic ink analysis. Synchronous ink analysis is very similar. We just simply have to call background analyze and handle an event called results, which will give us access to those results on the UI thread. So putting all this in a little bit more perspective here, one of the things we tried to do was when you're off doing the analysis operation, since this is not an instant operation, things can change in your document. So the user continues to ink and add information to the application as we're doing this. So when we redesigned the API, we wanted to make that easier for developers to keep things in sync. And as well, not waste time reanalyzing and re-recognizing stuff that you'd already done before in the past, and just really focus on the stuff that needed to be done. With that model, we came up with a mechanism that lets us prune down the data that's needed. So I'm going to walk through a little bit of a sample here and explain basically 3 concepts: pruning, cloning your information to a background thread, and then finally reconciling all that background work that we did back into the UI thread. So what this diagram represents here is kind of on the left-hand side, we've got the application's UI thread and an analyzer. On the right-hand side, we've kind of got our background thread here. So time just sort of progresses down this diagram here. And as the user's adding stuff to their application, we just simply sync to that stroke event. You tell us that the user's added a stroke or removed a stroke. We just sort of keep track of that stuff. Then at a time that's convenient for you, the application, you just simply call that background analysis operation. That's going to kick off the first stage here, which is the pruning step. So instead of us simply grabbing all of the ink data that you told us about, pulling all of that and re-recognizing it, we're just simply going to look at the data that is relevant to the current operation. So if we've never analyzed anything before in the past, we're going to pull it all in. If we've analyzed everything but one stroke, we're going to try and pull in the minimum set of data that we can to analyze that one stroke. Now, what that might mean is that might mean we pull in an entire paragraph of ink. That might mean we pull in an entire page of information. We more than likely, if you had a multi-page document, we won't pull in multiple pages. Or it might mean we don't pull anything else in. If you've got one little isolated stroke at the bottom of your page and a whole bunch of stuff at the top of your page, we'd only pull that one little isolated stroke in. We're going to go off and do that in the background operation. So in order for us to do that in the background operation, we need to clone the data. And the reason why we clone the data is we then let you, the application, which has primary control of this data, go and do what you want to it. So that can mean that while we're off in the background performing our layout analysis and performing our handwriting recognition, the user can be off adding more strokes to the application or modifying those strokes that we're currently recognizing on the background thread. So when that happens, it effectively causes what we call a collision. So when we've got our results ready after doing our background operation, we now want to tell you about those results. You want to integrate those results back into your application. So that kicks off our reconciliation process. And what we basically do is we say, okay, what's the current state of your document? Find out what all the strokes that exist in that document are, and then look at all the strokes we had in the background, look at the results we had, and say, okay, if something has changed that we were analyzing in the background, we throw our results out, we set a little dirty region on the application so that the next time background analysis is called, we'll reanalyze that area that collided where those changes caused a conflict. So this way here, you don't have to worry about keeping in sync. What did the user do? What did I analyze? It's just all going to work fluidly for you by us reconciling those changes down for you. So you don't have to worry about virtualizing out any of your document. We'll keep it trimmed down to the minimum set that's needed to maximize to minimize the time we spend on the background thread. We'll clone what we need to do it, and then we'll help you reconcile what has changed in the background. You don't need to worry about that on your end. Okay, so also in addition, to help you sync that data from the background thread, most applications already have an existing document model, and Ink is just an additional property, an additional data type that they stick into their application. We worked to come up with some different events that would help make that integration back into your application a little bit easier. If you have some sort of existing document model, whether it be a tree or a stream or whatever, that Ink's probably injected somewhere in that stream or somewhere in that document model. You know how to get to it. You know ideally where it's positioned, but not always necessary. And we just simply have a rich set of events that will raise to you if you only want to know about this on your own document model. If you simply want to use our tree to store all of your data, you could do that. I don't think you're going to get very far because it is a limited data set. But basically what each of these events are going to do is if we need to know about a particular region of your page, we're going to raise an event and say, hey, we need to know about the ink in this area of the document. That'll give you an opportunity to go query your document model, pull the ink data out, or if you're doing the situation of annotations, you want to pull out the 2D region for where your non-ink data is, your text, your images, whatever it is. You can simply tell us about those at that point in time when those events are raised. So the other thing, so supporting ink on text, I've kind of been talking about this and not really hitting to the point as much. The ink analyzer returns you a tree structure. So every time we analyze this, you saw a little bit of this in the early first demo there. We return a collection of context nodes that make up all of the information for our results. We'll have paragraphs, we'll have lines, we'll have ink words, we'll have drawings. These are all just simply what we call context node objects. Well, we let you create context node objects as well to tell us about information. So if I have a text word, I can go create a text word object, add that into effectively our result structure. You tell us the location of that text word context node. Next time we go off and analyze, if we've got ink near it, we'll create a relationship between that text node object and that ink object that we just analyzed. So moving along, because I'm getting short on time here. We're going to flip over to a final demo here, which, whoops, went too far, which is just kind of tying all this stuff a little bit together, putting that tree I was just talking to you about into perspective. So Shawn's now got flip over to Shawn. Shawn now has a little bit larger of a ink canvas demo set up here for us. Primary mechanism here is an ink canvas. We've then got a control on the right side, contained inside of our grid, which is going to give us a tree. So let's just go ahead and run this because we're right down to the wire here. And why don't you throw that up full screen there for us. And Shawn's just going to go ahead and he's going to start writing a few lines here. And this, again, is very similar to what we saw in that WinForms application. And you'll notice that as he writes, we've got that tree of results that's being calculated by the analyzer being built up on the side. And as he writes, we're getting a writing region set up. We're getting an ink word. Let me go ahead and just maybe click on one of those and cycle through what it's finding here for us. And again, it's building it up for us. Furthermore, you can go ahead and throw a text box in there, or sorry, a rectangle, a box. And that's now going to go off and got analyzed as a drawing. Now, when we added that in there, it looks like a couple of his letters, probably his I or his W, then got flipped over and thought of as a drawing. Again, that's a bug in our code base right now, which we'll clean up with time.
That's a bug, and it's an interesting feature. The real point there is the ink analysis engine is constantly running in the background to reinterpret everything you've drawn in the context of all new information that it has.
Yeah, great point. And so just quickly here, let's go ahead and click on that, the show ink tree results there. And one might as well show the reco results, see how we did there. And
It's cool.
what this is here, if we add a little more text, this would make a little more sense. But this tree down the bottom here is just simply an Avalon tree view control. And all we did to make this happen was, once the ink analyzer went and found what that first line of ink was, that first paragraph, we took all the strokes, we threw them in an ink presenter, we took that ink presenter, and we set it as an element in a tree view item control. We didn't do anything else, right? That was simply it. The recognized text, we took the ink paragraph, the ink paragraph context node, asked for the recognition results off of that, stuck that in along with the ink presenter and a little stack panel, stuck that entire stack panel into the ink tree view control.
Should I write some more?
Sure. Oops. So as Shawn will write here, one of the things we're aspiring to is the ability to tell you guys the indentation level for list items. So if Shawn were to start enumerating out a full list of things to do here, we would be able to traverse the tree and determine which one of these elements are sub-elements of other ink elements here, just as you would inside of any other outlining application, like inside of Microsoft Word. Since it doesn't like Shawn's handwriting, we'll see how we do here.
It probably doesn't like that rectangle there.
Yeah, you might as well just go ahead and erase that rectangle there. Probably just flip the pen over too, right? And all the while he's doing this, we're continually recognizing this in the background. The tree's getting built up. And away we go. So while he's doing that, I just want to make a point to mention the mobile PC and tablet PC SDK went live on MSDN and Microsoft Downloads today. So for those of you that want to go and get our latest and greatest version of ink analysis, you can go and download that today. I've also got it here on USB sticks, and it's on the CD if you guys haven't had a chance to pick those up. That is hot off the press from Microsoft as of this week. Right, and we've got a full set of instructions on what to install, what's the right order, how to get all this stuff up and running on your own systems. And so let's just toggle that showed ink tree there, just to refresh the view on it. And if we bring this into view, you'll now notice that we just simply parsed all of that data that was in there, and we've added it into a tree view control. So things to do, if Shawn actually hits the little tree button, it's kind of hard to see in Windows Vista with this current theme, but there is that little plus sign to expand and collapse stuff. So all of that stuff that was a list there is now all simply children of that Uber title things to do. But Wow Ink is Cool was left out of the picture.
Please, hold your applause. This is the first time I've ever done this demo, and it's got such great handwriting recognition results. Clearly, this is all smoke and mirrors, and there's no applause necessary.
Yeah, we secretly captured your handwriting while you were sleeping and retrained some engines on it. So anyways, that's the quick overview of what ink analysis is. If we flip back to our slides here, Again, go up to MSDN. You'll find that SDK there. Visit our developer center. There's a bunch of instructions up there for how to get going and get this stuff up and running. Tons of other mobile PC talks. If you guys haven't had an opportunity to go check out these, we mentioned these kind of at the top of the hour here. So feel free to check those out.
Tomorrow at this same time slot is Developing PowerWare Applications, Fun 319. You'll learn some cool, interesting techniques to minimize the battery life drain on the different types of technologies you employ. Synchronization Manager is tomorrow at lunchtime, I believe, 11:30 to 1. That's always really cool new stuff. The Vista platform SDK team are doing some cool new stuff with synchronization. Auxiliary display technology, that one already happened. That was a few hours ago. That's also really cool stuff. If you didn't see it in the keynote, or even if you did, if you haven't had a chance to get some hands-on experience with it, stop by the track lounge and talk to us, or the booth back in the expo hall. We have a couple of the Asus models, early production models of the aux display, and they're real. You can play with them. Touchscreen devices too. We have some touchscreen devices around. A couple other WinFX related talks that are coming up that are of interest. The content and reading experience talk, PRS 330, is a really good one. If you want to see more about Flow Document and Document Viewer and how all of that works, I highly recommend that talk. And there's a talk also on Friday of performance and tiering, PRS 327. You'll learn some good techniques for scaling down the performance impact of your Avalon applications based on different user bases.
Okay, and so with that, we'd love to open the floor up and questions, comments. There's microphones in the aisles if you guys have anything you'd like to ask. Other than that, thank you for coming and joining us. Again, if you want any of those USB sticks, feel free to come up and grab those.
One quick question. When you did the demo with the MIL and writing on the video,
Yes.
can you actually specify which frames to go on at any point? Like, can you actually afterwards decide I want to go from the frames like 1 to 1?
Sort of. So you may have seen that in one of the keynote demos. I think Michael Wallen demoed an application called healthcare or patient monitoring.
I didn't see it.
Okay.
No.
There's they do ink over video in that keynote demo. It's like a canned video of an ultrasound image, basically, and the scenario is exactly what you described, where the doctor pauses the ultrasound image at some points and marks, hey, it looks like a tumor here or something, right? And restarts the video and plays it back, and the ink plays back with the video. There's nothing built into Ink Canvas or Media Element to somehow synchronize strokes and frame-by-frame playback.
So it's something we'd have to do ourselves.
It's nothing more than 100 lines of C# code somewhere. Yeah.
Okay, thanks.
Would you guys, that test harness that you just showed there, are you guys going to include the code for that in the SDK so I could see how you guys did that WinFX application?
Sure. We don't have it in the current SDK that just went up live today.
Okay.
Hopefully we'll have enough for
but
everybody.
It's not that complicated to
There
turn
are more
around
of
and
these
add
in
that
the
tree
hands-on
view
lab.
control.
Yeah.
So we can definitely do that. If you want to get it now, come on up and give me your email address, and I'd gladly email you that project.
Cool.
To you for sure.
Thanks.
Yeah, so the question was whether or not there was shape recognition built in, and the answer is yes. The ink analysis APIs do have basic shape detection, so we'll do things like circles and squares and parallelograms and that kind of key sort of simple.
All right,
simple
we're down
shapes.
to 5 or 6 more here.
It will not convert the ink into those shapes because we don't know what kind of shape you're going into. Are you going into a GDI shape? You're going
There's
into,
more of these at
into
the
an
hands-on
Avalon WPF shape. So we basically give you the information to say, hey, this ink stroke or this group of ink strokes came back as a rectangle, came back as a triangle. And then you can do what you want with that information. You know the size. You know the
I just
key-
ran out, but
key
they
information.
have more at the hands-on lab area?
Yeah.
Never mind.
So at this point, we don't
I think there's more.
give
on
you
CD.
the actual angle of
That's more
rotation, but
obvious.
what we are looking to do is giving you specific hot points of information. So what are the key pieces that you know, so you could calculate that
We're out
angle,
of USB sticks, but
or
we have some
more
CDs here.
specifically draw a cleaned up parallelogram. Not in the builds today. That is something we're working on to get added into builds. So, Casey. It wasn't the gesture recognizer doing the shape recognition. We've, again, neural net-based kind of sort of training data that's coming in through a different stack, and it's more meant for background processing, not for kind of that quick gesture reco. If you wanted to sort of skip that and just get those quick results, you could do that by plugging in the gesture recognizer. You cannot create managed recognizers yet. All of the recognizers are still unmanaged recognizers. But again, our whole interface tech, getting access to them is managed. One of the things my talk did include was if you explicitly want to go to your own custom recognizer, let's say you created a math recognizer as an example, it would have to be an unmanaged recognizer or a managed recognizer with the unmanaged interface exposed on it. You could plug that into ink analysis. The only caveat there is that you as the developer or as the application kind of end user have to classify the strokes. You have to say this set of strokes goes off to this math recognizer because we don't know how to figure out what stroke goes to your specialized recognizer. You'd have to tell us. No further than what you could do with V1. So you'd still have to go and create your own word list, coerce to it. The other thing, though, that might be of interest, I kind of mentioned at the top of, was the ink personalization service. So that kind of has two parts to it. One is it's going to go and let you provide training data for how to correct results. And the other part is it's going to actually go and, with your permission, harvest terms off of your system. So check things like your email and say, okay, what are the common words that you write and common phrases that you have? And you can basically, in some cases, help retrain some of those words that you might be missing from the dictionary through that mechanism. Yeah. Other questions? Yeah. Yes. So at this point, no. I mean, it is kind of an active thing that's going on and kind of running always in the background once you turn it on. But it's not something where at this point in time, and this is kind of our first rev of it, we could basically let third parties take their recognizers and get access to all of that training data. Right. Right. Yeah. Yeah. Now. Yep. Right. At this point, that's not something that we're exposing. There's kind of some legal and personalized issues that would relate to that. We don't want to open up a user's data to everything at this point. There's also just scheduling constraints on our end, trying to get the first rev to work. So for initial Windows Vista, you won't be able to, as a third-party app developer, get into that. But doesn't necessarily mean that in the future we're completely closed to doing that. Yeah, I mean, I'd hate to see user have to do it twice, though. Once for a third party, once for us. So I think down the road we'd rather go that route, but for the first rev, yeah. Cool. Yeah, that would be great. I'll make sure that we send that to you. Great, thank you.